Ever wondered how AI can predict the future when data is messy, incomplete, or arrives at weird times? Let's dive into the wild world of time series analysis, where weather reports, stock prices, and hospital records collide in a chaotic dance of irregularity. Today, we're exploring a breakthrough study that's redefining how AI tackles real-world data, blending numbers and text to make smarter, more reliable predictions. Let's break it down. Most datasets we train AI on are clean, uniform, and, let's be honest, a little boring. But the real world? It's a mess. Think of healthcare records with missing appointments, climate sensors that glitch, or financial data that jumps around. These are irregular multimodal time series, data that's asynchronous, full of gaps, and packed with unexpected patterns. Why does this matter? Traditional models assume data arrives like a well-oiled machine. But in reality, observations might come from different sources at different times, with delays, missing chunks, or even conflicting signals. For example, a patient's heart rate monitor might tick every second, while their doctor's notes are added sporadically. How do you make sense of that? Enter Time-IMM, a groundbreaking dataset and benchmark designed to tackle these real-world challenges. Let's unpack it. Time-IMM isn't just another dataset. It's a treasure trove of 9 distinct types of irregularity, grouped into 3 main flavors. 1. Trigger-based irregularities, like earthquakes or sudden events that spike data collection. 2. Constraint-based irregularities, think human schedules or resource limits that dictate when data is gathered. 3. Artifact-based irregularities, technical glitches, delays, or asynchrony that mess up the timing. But here's the twist. Time-IMM doesn't just include numbers. It pairs them with textual data, like clinical notes, sensor logs, or event descriptions. Why? Because context matters. A patient's lab results mean more when you know their symptoms, or a sensor reading is clearer with a log entry explaining the environment. To make sense of all this, the researchers built IMM-TSF, a benchmark library that lets models handle this chaos. It's like a toolkit for AI, with modules that blend numerical data and text, and strategies to prioritize recent info or focus on key patterns. And the results? When they tested these methods, models using multimodal data, numbers, and text outperformed traditional approaches by up to 38% in some cases. That's huge. It shows that embracing real-world messiness can lead to smarter predictions. So what's next? Time-IMM and IMM-TSF are open source, so researchers everywhere can use them to build better models for healthcare, climate science, finance, and more. It's a step toward AI that's not just smart, but practical. If you're curious, check out the dataset on Kaggle and the benchmark library online. The future of time series analysis is messy, and that's a good thing. Thanks for watching and stay curious. Now let's get technical. How do models actually process this chaos? The key lies in data padding and feature engineering. Imagine resizing photos to fit a frame. Scientists do the same with time series data, padding it to a uniform length so models can process it without confusion. But padding alone isn't enough. They add special clues to help the model understand time and missing information. Think of it like giving the model a roadmap. Timestamps tell it when each data point happened. Masks highlight where data is missing, like a calendar with blank spots. Query features let the model know when it needs to make a prediction, like asking, "What's the weather like next Tuesday?" Here's where things get interesting. The model uses 2 key components. 1. TTF, timestamp-to-text fusion. This part connects time data with text. For example, if a news article mentions a storm on a specific date, the model learns to link that text to the corresponding weather data. It uses math to weigh how recent or relevant each text snippet is to the prediction. 2. MMF, multimodality fusion. This blends numerical data, like temperature readings, with text, like news articles, using smart techniques. Imagine merging a weather forecast with headlines about climate change. Both influence the model's final guess. To test this, researchers compared different approaches. They found that using pre-trained language models, like GPT, to process text outperformed older methods like Doc2Vec. Even when data was messy or incomplete, the AI learned better by leveraging rich, pre-trained knowledge about language. This work isn't just about better predictions, it's about making AI more adaptable. Whether it's forecasting hospital admissions, stock market trends, or environmental changes, these techniques help models handle the real world's chaos. And that means smarter, more reliable AI for all of us. So next time you see a prediction, remember, behind the scenes, AI is juggling time, text, and missing pieces to make sense of the future. Thanks for watching, stay curious.